Hi everyone, welcome to the fifth lesson for topic 3.2 growth and decay in sequences, or you can call this as the second part of lesson 4 as well. So we are going to continue our previous lesson. Okay, so I'm not going to read through the learning outcome again because we did that during our physical class already. So basically the thing that we have covered in the previous lesson is we understand that when we try to display the term for arithmetic sequence or geometric sequence in our calculator, so when you try to observe the scatter plot, right, then you realize that for arithmetic sequence, it will give us a linear graph. Then for geometric sequence, it will give us an exponential graph, or it's like a graph that's alternating if let's say you have a negative r. Okay, then for the last part, we actually stop at a part where we try to use arithmetic sequence to model and to analyze some practical situation which involving linear growth and decay. So we are going to cover the last part in this video, so which we are going to use geometric sequence now and to model our daily situation as well. So the growth and decay that we are going to discuss is the geometric growth and decay. Okay, so let's start the video. Alright, geometric growth and decay or geometric modeling. So they are the same thing, but yeah, basically we say that we use geometric modeling to model the situation that involving geometric growth and decay. Okay, so a sequence displays geometric growth and decay when each term is some multiple, or you can call it as ratio as well. I think previously we used the word ratio. So it's some multiple or ratio of the preceding term. So we know that for geometric sequence, you have a common ratio r, right? So if let's say the multiple is greater than 1, which means that if r is greater than 1, then you know that you are going to get a sequence that's increasing, that becomes larger and larger when you go all the way. So it corresponds to geometric growth, okay? Whereas when you have a multiple that's less than 1, in this case, we are talking about the multiple that less than 1 but greater than 0, okay? Because you see, right, the words that we use is like growth or decay. If let's say we have a negative r, then you know that all your sequence will alternate like positive, negative, negative, and that doesn't actually indicate growth or decay because it just growth then decay, growth, decay, growth, and decay. You cannot see a trend over there. So that's why in geometric modeling, in most of the situation that we will be encounter, right, the r is always positive. It's just that it's greater than 1 or lesser than 1. Okay, so a multiple that's less than 1 will correspond to geometric decay. Okay, so these are some practical situations where we will be using geometric modeling. So the first one is when we try to analyze a compound interest loan or investment. Okay, so we are going to talk further for this part when we move on to topic 4.2 when we discuss about financial mathematics. But you remember, right, for arithmetic sequence, we use it for like simple interest. Then for geometric modeling is compound interest. Okay, so you'll understand this further when we move on. Then after that, the second one, it can be like the growth of the bacteria population that doubles in size each hour. Okay, so the size is double, right? So you can imagine if let's say you start with 2, then it becomes 4. Then you double again, then become 8, then you double again, become 16. So in this case, you cannot use arithmetic sequence, right? Because their common difference is, their difference is not common. Like this is 4, this is 2, this is 4, this is 8. But in this case, they have a common ratio, right? So double, double, so times 2, times 2, times 2, times 2. And that's our R. So that's why we need to use geometric modeling. So the last one, calculating the value of office furniture at the end of each year by using reducing balance method. Okay, so the one that we use arithmetic sequence is called as the straight line method. So meaning that you have a specific value, like for example, the printing machine that you see in our handout or in your own exercise, and you realize that they talk about like maybe after you print out 1,000 copies of printing, then how much value the printer will depreciate. Or you talk about like after every year, then how much depreciation is your furniture. So for reducing balance, we normally talk about percentage. So it will be something like after this year, then reduce for 5%. Then after another year, reduce for 5%. So you see, right? for every 5%, it will be depending on your previous value, but it's not the original value that you have. So in that case, you only have a common ratio rather than a common difference. Okay, so in the questions later, then you will be exposed to this kind of situation. All right, so now let's try to look at example 1, so which is question 7. Okay, examples. So for all the problems below, write down the recursive rule and the n term rule for the sequence. Okay, so it's just apply for this set of handout. Yeah, so I hope you guys understand that it's not every questions you need to write these two things, but it's just for you to practice in this handout that you are actually using your GP to solve all these questions. So that's why I want you guys to just practice it. Okay, 7. Adult purchased a house and it is valued at 650,000 in the first year. If it increases in value by 5% each year, how much will the house be worth in the 10th year? Okay, answer correct to the nearest dollar. So in this case, then I think it's very straightforward. Then you know that the common ratio is the house will be increasing in value by 5%, 5%, and 5%. So that's why in this case, I hope that you are familiar with 5%, which means in decimal, it will be 0.05. So you have an original value that stands for 1, right? Then after that, you plus another 5%, then which means it will give you 1.05. So in this case, then your common ratio is actually 1.05 because it increases for 5%, right? So that's why in this case, then we can try to write our recursive first. So Tn will be equal to R and then multiply the Tn minus 1, multiply the previous term so you can get the next term, right? So increases, 5%, 5%. So times 1.05 times 1.05 and so on. Okay, so your T1 is the value of the house in the first year, so 650,000. Okay, so now let's try to do our n term rule as well. So Tn will be equal to ARn minus 1. Okay, so this is our formula. So I hope that you can remember this right now. Okay, so the A is our first term, our initial term. R is our common ratio, then n plus 1. Okay, so in this case, you doesn't really need to simplify lah, so just just leave the part here. Okay, so now the question want to find out be worth in the 10 year. So T1 meaning is the first year, right? So in the 10 year, which means it's quite straightforward, you are finding T10. Okay, so you know what's the 10 term. So which means the value in the 10 year. So 650,000, then 1.05 to the power of 10 minus 1. Okay, so if you were to simplify, if let's say you want to straight away use your calculator to press it, also can. So do not really need to write the 9 here lah. Okay, so after you press it, then you should be able to get 1,008,363.34. But in this question, the question wants us to correct to the nearest dollar. So that's why it's approximately equal to dollar sign. So 1,008,363 to the nearest dollar. Okay, so that's the answer for question 7. So I think it's very straightforward. Okay, so now let's look at example 8. Okay, question 8. A population of endangered eastern barred bandicate consists of 162 individuals in its first year. So if this population decreases by 16% each year, how many bandicates will be left after 5 years? Okay, so same thing in this questions, you can see that the population decreases by 16% over the year, right? So that's why, which means that what is the common ratio? So what do you multiply when you want to get something that decreases by 16%? So you have 100% in original, right? Then after you decrease 16%, which means you left with 84%. So which means when you multiply, then you will multiply 0.84. Okay, so I hope that you are very familiar with this idea, right? This is like what you have learned in secondary school or even like primary school when you learn about percentage or decimal. Okay, so R is 0.84. So now when we move on, then we need to write down our recursive first. So Tn will be equal to, so when you get your next term, you use 0.84 to multiply your previous term. So times Tn minus 1. So in this case, our T1 is 162. Okay, so same thing, n term rule. So Tn will be equal to A, in this case is 162. R, common ratio is 0.84. Then after that, n minus 1. Okay, so the question want us to find out how many benefits left after 5 years. Okay, you see, right? Then you need to understand what is the information that given, because in this question they say in the first year. So T1 meaning that the value in the first year. So if you want to find after 5 years, then which means is in which year? Yeah, so I hope that you have a clear idea that you are finding the number of people remain in the 6 year, because the 6 year meaning after 5 years, right? Then you reach the 6 year, so that's why you get T6. So in this case, we need to substitute our T as 6. So 162 multiply 0.84 and then 6 minus 1. So in this case, then is we can straight away press this law, or if you want to simplify again, so times 0.84 to the power of 5. Okay, so after you get the answer, then you will get 67.75. So my question is, can you leave your answer like this? Yeah, so it's no, because benefits is like how many individual that you left, am I right? So that's why you can't count like 0.75%. Okay, so in this case, it will be depending on you. So sometimes what they want to see is like how you actually work this out. So the argument here can be, yeah, you can see that it's actually lesser than 78 already. So that's why you could round it at 67. Or someone can actually say that, I mean, it's not decreases until 67 yet, and it's nearer to 68. So I think in this case, we can actually accept both. Okay, so 67 or 68, just make sure that you must write down in full value. Okay, so it's a whole number because you are getting like how many benefits here. Okay, so that's question 8. So now let's move on to 9. Okay, question 9. A colony of bacteria contains 100 cells when the experiment starts. If the population doubles every 20 minutes, how many cells will the population contain in 4 hours? Okay, so for this question, right, I want to bring out a very important concept is that the number of term that you try to set for your term is not the most important thing for the question. So what is more important is your last answer. Okay, so which means in another words, right, I might be finding the 5th term and the other person might be finding the 6th term, but at the end we still get the same answer. Okay, why is that so? Is because of our assumption on the initial term might be different. So that's why if we have different initial term, then it's going to affect the number of term that we are going to find at the end, but then you still get the same answer. Okay, so I'm going to show you two approach for this question so that I hope that you understand what I mean here. Okay, so let's do the one that we normally do. Okay, so in this case, you know that when the experiment starts, the colony, the bacteria is having like 100 cells. So that's why, and the population doubles every 20 minutes, right? So which means that it's a geometric sequence because you have the ratio of 2. So in this case, when we try to write our recursive rule, that is going to be n term is equal to the previous term and then times 2. Am I right? So, or you can write 2 in front, is the same thing. Okay, so after we got this, then meaning that we try to set our first term is 100. Okay, but I want you to remember this. The 100 here, when you write first term, is not for the first 20 minutes. You get what I mean, right? Because this 100 cells is when the experiment start. So which means if let's say you want to find out the population in 20 minutes, then it will eventually become T2 already. For the first 20 minutes, then that's T2, right? Because following this idea, then our T1 is when the experiment start. So T2 is after the first 20 minutes. Okay, so the questions want to find how many cells will the population contain in 4 hours. Okay, so let's try to write down our n term first. So Tn is equal to A, in this case is 100. So R is 2 and then n minus 1. Okay, so the question want to find out I mean how what is the population in 4 hours? Am I right? In 4 hours, meaning in another words, it's like after 4 hours, then how many cells do you have now? Okay, so my question here is that when you have 20 minutes for one cycle, right? So after 20 minutes, then doubles. After 20 minutes, then double. So in 4 hours, how many 20 minutes that you have? So I think this is very straightforward. So you have 4 hours. So each hour you have 60 minutes, right? So when you try to use like the total minutes, you divide by 20 minutes, then you'll be able to get 12. So which means that after the first 20 minutes, then it will be T2. After another 20 minutes, then it will be T3 and so on. Okay, so you want to get in 4 hours, so meaning that it will be after 12 times of 20 minutes. So what is the T that you are actually finding? Is it T12 or you have another idea? So the idea is it should be 13 because you want to find out how many cells the population contain in 4 hours, right? So that's why in 4 hours, then it will be after 12 times of 20 minutes already. So which means your first term is when the experiment starts. So after, okay, let me try to write down like this. So which means T2 to T1 is the first 20 minutes. Then after that, the second 20 minutes is already T3. So you imagine after the 12 20 minutes, then it will be T13 and we want to find out what is this. So that's why we are using the 13 term. Okay, so I hope that you can get the idea. So that's why it's 100 and then 2, 13 minus 1. So in this case, then it will be 100, then 2 to the power of 12, and that gives us the answer of 409600. Okay, so now I'm going to show you a different approach here because some people might feel that, hey, can I try to set my first term as the first 20 minutes? Yes, you can do so. So which means that what happened here is that when you try to write your recursive, right, it's the same thing. But in this case, instead of doing T1 equals to 100, because you want your 1 represent the first 20 minutes, right? So which means the T2 just now eventually become your T1 here. So this is when the experiment starts. So that's why it will be like T0 equals to 100. Why is that 0? Because it's 0 minute. After the first 20 minutes, then only I counted it as my T1. So how do I get my T1? My T1 will be equal to 100 times 2, right? So that gives us 200. So that's why when you try to write your n-term rule, so it will be 200 and then 2 and then n minus 1. Okay, so what's the difference between these two is that you imagine if let's say your T1 now, meaning after the first 20 minutes, then which means contain in 4 hours, which means after 12 times of 20 minutes, right? So that's why the T that you are going to put here, it will be T12. So when you substitute, then 200 and then 2, 12 minus 11. So you have 200 and then 2 to the power of 11. And by using your calculator, you should get the exactly same answer like what we did in front. So that's why you look at these two questions, right? The first one I use 13 term and the next one I use 12 term. But at the end, I still get the same answer. Why is that? So because my assumption on the initial term might be different. So for the first approach, I might think that my T1 is when the experiment starts. So when I write T2, which means it's the time that after the first 20 minutes. So that's like T2, my second record. Then after that, when I continue and so on. So that's why when I try to find out how many cells is there in 4 hours, so I will do T13. I try to find out for the 20 minutes that is after 12 times of 20 minutes, right? But in this case, what I mean here is that the initial term for me is 200. So which means that I do not want to think like the first approach, but I want to think it as imagine it as the idea of T1, meaning after the first 20 minutes. So that's why if I want to find out in 4 hours, then I will use T12, okay, then to get my answer. So I hope that you can get the idea. So yeah, it's just your own preference, like which way you prefer. But what is most important is you understand why do you do so. Okay, so yeah, that's the thing. Okay, so now let's move on to question 10. Alright, question 10. Isabel started an online store and sold 50 items in her first year, and she found out that her sales increased by 20% each year. So, in which year did she first sell over 2,000 items? Okay, so in this case, then you can see that the sales increasing like 20% each year. So, which means that our common ratio here it will be 1.2. Okay, because from 100% increase 20%, so it's 120. So when you try to change it to decimal, then this is how you get 1.2, right? So that's why in this case, then it will be Tn will be equal to n minus 1 term and then times with 1.2. Okay, or you can write 1.2 in the front, it's the same thing. So don't forget your T1 here in the first year, so it's 50. Okay, so let's write down the anthem rule. So Tn A and then R n minus 1. Okay, so questions want to find out what is the first year she first sell over 2,000 item. So in this case, then we know that it's similar like how you solve AP question. So to approach that, you can use the first one, generate your sequence. The second one, you solve the equation. Okay, so I mean, if let's say you ask me like which option is better, then I'll say generate the equation is better. So which means in this case, we know that the Tn must be greater than 2000, then we just try to generate the sequence in our calculator. So let's generate the sequence. So menu, data, generate sequence. Okay. So in this case, depends on you. You want to type in the recursive rule also can, or you want to try type in your anthem rule also can. So depends on your own preference. So 50 and then times 1.2. Okay, sorry, let me try to write it in a better way. Okay, 1.2 to the power of n minus 1. Okay, then after we got this, then you can put in your initial term. In this case is 50. Alright, so yeah, depends on you. I think 100 is much enough. Okay, so okay, then after you got this, then now you can try to check it. Okay, so yeah, times 1.2, then we want to find out what's the first year that she sell over 2,000, right? So you just go continue to check. Yeah, okay. So you can see that for the 2021, you have 1916.88. Then after that, T22, then you have 2300.26. Okay, so you can just write down your answer by writing down these two terms. So T21 equal to 1916.88. Okay, you must write both, yeah, because you need to prove that this is the first one that exceed 2000. Okay, so after you got this, remember to write down your answer in which year. So which means in this case is the 22nd year. Okay, make sure it's in the 22nd year. If let's say you try to write down after 22 year, that's wrong. Okay, so because if let's say you write that after 22 years, it means 23rd year. So it's not correct in the context here. So which means it's in the 22nd year. Okay, so the other alternative that you can try to do is by solving the equation. So this is what we did previously, right? So 50, okay, and then 1.2 and minus 1 greater than 2000. So in this case, you can try to use the calculator to help you to do that as well. So just open a new page. Okay, so calculator. So same thing, we can use and solve. Then you just put in, so 50 times, okay, and then 1.2 to the power of n minus 1. Okay, equal to 2000, and after that we are finding for n. Okay, so you enter, then you can get n is 21.23. So that's why when you try to write down, then it will be n should be equal to 21.2328. So that's why the first value that exceed 21.23, it will be 22 lah. Okay, but if you are using this, then normally like what I said, it's better that you substitute back your answer and you check that whether you got it correct or not. So if you were to ask me which one is better, then I would say go for this one is better. Okay, because definitely if you generate the correct sequence, then your answer here should be correct already. Because if let's say you do this, then it's like solving an equation, especially you are using your calculator to help you to solve that, right? So that's why it's still important for you to substitute back your answer and you check. So in this case, then actually you are doing the checking process already. So this one is, a better option in this case. So that's why it's the same thing. So in the 22nd year. Okay, so let's move on to question 11. Okay, question 11. The value of the car depreciates at 5% per annum if the car costs 225,000 at the first year. After how many years the car costs below 100,000 and state the value? Okay, so for this question, since you need to state the value, so that's why it's easier for us to just generate the sequence, right? So that's why the car depreciates as 5%. So that's why if your first year is 100%, then depreciate for 5%, which means you will times 0.95. So in this case, our common ratio here is 0.95. So when we try to write our recursive rules, so the n term is given by 0.95. It's the same thing whether you write 0.95 in front or you write times 0.95. Okay, and the T1 is the cost at the first year, so it's 225,000. Okay, so same thing, let's try to write down the anthem rule also. So 225,000 A R and then n minus 1. Okay, so now the same thing, the question want to find out how many years the car costs below 100,000. So in this case, we are getting our anthem is lesser than 100,000. Okay, so let's generate the sequence. So same thing, data generate sequence. Okay, so key in 225,000 and then 0.95 to the power of n minus 1. Okay, so initial term is 225,000. So same thing, if you doesn't want to change anything, just okay. Okay, so you will see the sequence generate here. So in case, if let's say you scared that there's something that you key in wrongly, right, then you always can try to check out with your normal scientific calculator. If you use the first term and you multiply 0.95, you get the second one. Then when you continue to times 0.95, then do you get this one? Okay, so you can actually use your scientific calculator to check. So in case that, you key in anything wrongly here. Okay, so when you move on, then we can see the first term that goes below 100,000. So it should be here. Okay, so same thing, we need to write down these two terms. So the 16 term and the 17 term, okay, together with its value. So in this case, then we have T16 is 104,240.53. Then T17, you have 99028.50. Okay, so let's go back to the question again. You see the question asks after how many years the car costs below 100,000. So what the question one is after how many years? So which means in this term, you can see that it's the 17th term is the first value that goes below 100,000, right? So for the 17th term is actually mean at the 17th year. So meaning after how many years? Yeah, so in this case, it will be after 16 years. Okay, so you must remember the number that you write, right, should be according to the question. So if the question asks you like at which year, then which means your answer is at the 17th year. So the question asks after how many years, then it will be after 16 years. Okay, so you need to always go back to the question and state the value. So the value is, then you just write down the value that you got. Okay, 99028.50. Or else you can always use and solve also, then you will be able to get the same thing. Yeah, but like what I said, this is a better option because at the end you still need to get this value. So it's either you do and solve, then you substitute back your equation, or you use this. Okay, so this is much easier. Okay, so now let's look at the last example. Alright, a painting appreciates by 16% per annum. So sorry, I forgot to explain this in the previous question. So PA mean per annum, so which mean each year. So in other words, the price of this painting increased by 16% each year, okay, per annum. Okay, so it is currently worth 20,000. So how much will it be worth in 1 year, 2 years, or 3 years? So after 1 year, then you have the price will increase for 16%, right? So which means you can straight away use your scientific calculator. So 20,000 times 1.16, then you can get your how much will it be worth in 1 year. So that give you 23200. Of course, you can generate the sequence as well. You will get the same thing. Okay, so 26912. So times another 1.16, then we have 31217.92. Okay, so depending on you, I mean, later we need to generate the sequence as well. So I'm just going to show here. All right, so yeah, in this case, since you doesn't write your anthem rule yet, right? So that's why if you want to use your recursive, then yeah, feel free to do that. So how do you get that? It's 1.16 then multiplied by the previous term, right? UN minus 1. Okay, so initial term is 20,000. Okay, so you just tap. All right, then you can get all your value here. Okay, so you must be a little bit, I mean, careful that in this term, right? Because when you try to put in your initial term as 20,000, so which means the calculator treat like your T1 is 20,000. So which means in this case, T1 is your current worth, but it's not the price in your first year, because in 1 year, then it's already 2300, because it's like after 1 year already, right? Then you get this amount. So T2 meaning for the second year, then in 1 year lah. So that's the idea. Okay, so when we go for B, how much increase in the price when it is in the 11th year? Okay, so which means in this case, then you need to decide if, let's say, depending on you, whether you want to treat this as your T1 or you want to treat this in your T1. So at the end, you still get the same answer, but then the number of term that you are using is different. So in this case, since we already use, I mean, the recursive rule, right? So which means in this case is Tn, okay, and then equal to Tn minus 1 multiply 1.16, and we already put in our calculator T1 is 20,000. Okay, so which means that our initial term start with 20,000, so which means it's in the first year. So if we want to find out in the 11th year, then which means that we are reading the T11. Okay, I hope that you get what I mean. So if let's say you want to treat this as T1, so meaning this is like in 1 year, then which means later when you want to find B, then you should use T10, because your T1 here is like meaning that it will be worth, how much will it be worth in 1 year, 2 year, 3 year. So when it's in the 11th year, which means I can try to rephrase it like how much will it be worth in 10 year. So that should be T10. So yeah, depending on which initial term you want to set as. So in this case, if you want to write in full, then we also need to write down the anthem rule as well. So A, in this case we are treating T1, right? So A, then R, and minus 1. So yeah, since it's okay, I think we can straight away. So T11, right? So 11 minus 1. Okay, so by using calculator, and that will give us 88,228.71. So let's try you see your calculator as well. So check for T11. Okay, so when you go down, then you see you get the exactly same value here. So 88,228.70. So that's why this is correct. Sorry, I think this is 0, is it? 7, yeah, 70. Sorry, my mistake. Okay, so after you got this, then we can try to find out the percentage of the increase. So percentage increase. So we try to compare to the original value, right? So 88. Okay, so you're finding the increment, right? So that's why you need to find out how much increase first. So 88,228.70, then minus off the original value, then you can find out how much money, how much value that it increased. Then after that, divide by the original value, so you can get the percentage of increment, then times 100%. Okay, so remember to times 100% now, so you can get 341.14%. Okay, so you see the I mean the value actually increased like quite a lot here. Okay, so yeah, that's pretty much of it. So now see how long will it take before it is worth 50,000. So in this case, just check our calculator for that. So more than 50,000. Yeah, okay, so you can see at the 7th term is 48,000 something. Then after that, the 8th term is 56,000. So this is the two value that we want. So, and you need to note this down. All right, so let's try to write down our answer here. So we have the 7th term is 48727.93. So T8 is 56524.39. Okay, so by looking at this, then you know that at the eighth term, then the price of the painting goes over 50K. Sorry, yeah, 50K. Okay, so how long will it take? So which means that how many years will it take? So yeah, you still remember what is that meant by your number here? So T1 is the initial. So when you write T2, which means it takes 1 year to reach T2. So for T8, then which means it will actually take 7 years, right? So the eight value, so because this is T2, so when you write T2, it's after the first increment, so which is after first year. Then when you write T3, it's after second year, right? So that's why when you have T8, it's actually after 7 years. So it takes 7 years to reach 50K. So that's why in this case, you should answer 7 years. Okay, so again, always go back to the question. It's either you write it takes 7 years, or you can write at the 8 year. But I will still, I mean, still encourage you to always go back to the question log, because it will be a bit risky if you write 8 year, then you forget to mention that you actually mean like in the 8 year. So it takes 7 year. So that's why in this case, T78, so your answer should be in 7 years. Okay, so yeah, that's it for this question. All right, the same thing, you can try to use NSolve to solve it as well, but you will get n equals to 8. But remember to mention that, in the 8 years, so that's why it takes 7 years to do that. Okay, so yeah, that's basically the part for our example. So spend some time to do your work and also to start to do your revision for your test. So if let's say you got any question, then feel free to just contact me personally. Okay, so yeah, that's it for today's session. Thank you.